Live from your local news leader, Matthew White, Amanda Brennan, and Central Illinois' most accurate forecast with meteorologist Adam Shawinski. You're watching The Morning Show at 9 on WCIA3.
Alrighty, Central Illinois, welcome back to The Morning Show. We hope you enjoy and appreciate science because we have another Wise Guy segment where this morning we're joined by Wise Guy Paul Kwiat today to talk about how sparks are made. And so, Paul, we're always glad when you can join us. Let's dive in.
Yeah, nice to be here. So I thought since this is Valentine's Day week and people often talk about sparks, we'd talk about a different type of spark. And today I'm not going to talk about the kind that come like from a lighter where you just have a little spark that comes out. That's a kind of a frictional, a thermal one. I want to talk about electrical sparks, kind of wrapping up a lot of the things that we've been talking about. Okay, so if we go to the just the first slide, just to set us, we know again matter made of charges, charged particles. Protons have positive charge. Electrons around them have nucleus negative charge, and we have electric fields that come out of those positive charges, go into the negative charges, and we can talk about two different types of materials. We can have materials where there are free electrons that can carry the current. Those are conductors, and then we have insulators where there are no free electrons. They're all kind of bound up, so we don't get any current. But if we can apply an electric field, so if we go to the next slide, if we apply a strong electric field to even something that's an insulator, also called a dielectric, if the electric field is strong enough, you can actually break down the material, and the thing that was an insulator suddenly can have a lot of free charges that can become a conductor. And for example, with air, if you can put more than 30,000 volts per centimeter on air, it'll break down and you get a spark. So that's what all we're going to try and do now is how do we make these high voltages? So everything else is like that. So we've been talking about this other phenomenon. If you put different materials together, then we get this triboelectricity. So just last slide, and then we can come to demos here. If I put different materials together, I can transfer charge from one to another. And so we showed that about like putting balloons on your head and things like that. So what this thing shown on there is a Van de Graaff generator. It's fun. So I've got here just something that has a belt, and when I turn this on, it's going to bring electrons from the bottom up to the top, and it's going to charge the top. And I'm just going to put this on here, and then we're going to see if we can get a little spark out of it.
Ooh, should I stand back?
No, it's fine. It's tiny. It's tiny. So I can actually see a little spark here. There's a little, really tiny one.
Oh, I do too.
Yeah, okay.
It's a little white spark.
Yeah, a little white spark that's right there. Okay, let's talk about a different way, because we've been talking about that one already in our studies, so to speak. Okay, so the next thing we're going to do is a totally different phenomenon. It's called piezoelectricity. So if we take the next slide up. So if we take some materials, some crystal structures, and you put a big pressure on them, they'll actually generate a voltage across them. It's called a piezoelectric material. And the more pressure you can put on, the more voltage you can get. So if we come back to us again, I have a little demo of that here. So there's a crystal in here, and when we crank on this thing, it's going to put a pressure on it. And I'm looking at these two little needles. I'm looking at the voltage. There'll be a little voltage across them, or actually a high voltage. And so if I'm going to pump this thing up and down, I have to just hold it. And when I pump it, there's a little bit of a, there we go. We have a little spark that's going back and forth between the two. Yeah, and there we go. We can see it now on the camera. Okay, there's an easier way to make the same thing. This is the same thing. This is the end that I'm holding right here. This is the end of a lighter, basically. There's a little piezo, and when I pop this, now we can get this nice, beautiful spark that's going in between these two. Yeah. Well, that was going. If they're too far apart, then of course it won't spark. There we go. Okay, so now we get this nice spark, and in fact, that is what is inside. That is what is inside, for example, one of these lighters. Yeah, so when I
grill.
Yeah, exactly, or to light a candle for Valentine's Day, right? Exactly. Okay, so then the last type of way of getting a spark is going to be totally different yet again. So if we go to the next slide. So it turns out that if I have a current that's running, that current will generate a magnetic field. And I can use, if I have, for example, a coil of current, that'll generate a stronger magnetic field. And if I put something like a nail in, I can get an even stronger magnetic field. So if we come back to us here, I have here just some batteries that are hooked up. I'm just going to hook it up to this coil. And that is going to make here then, that is going to make an electromagnet. Right there. Ooh, so I've turned this thing into an electromagnet. Okay, great. So that's how we make a magnetic field. So if we just go back to the last slide now, the thing is that nature is such that if you have, there's a thing called Faraday's law, that if you have a changing magnetic field, a changing flux, it'll create a voltage. And so since the magnetic field is like the current, and we have a changing current, that'll make a voltage. So this is sort of the principle of how an ignition coil works or a spark plug works, and we can see it here too. I'm going to try to push these in front so that we'll be able to, just going to rotate these around so we'll be able to see them a little bit. And this is the last demo that we have. Okay, so right now there's a current that's running through there, and I'm making this magnetic field, but I'm going to break that by disconnecting this. And as I disconnect this, you see I can get sparks that are coming off this little tip.
I did see one.
Yeah, we did see one. Oh, there we go. There's some other sparks that are coming off. And that's because of the fact that as I break the current suddenly stops, then there's a voltage that's generated that tries to prevent that from happening. And in fact, that's how you can destroy a lot of electronics. When you disconnect things, that's one of the reasons they want you to disconnect like your memory stick before you pull it out.
Okay.
Okay, lots of ways to get sparks.
Absolutely, Paul. We can't thank you enough for all the time that you gave us this morning.
Oh, thank you so much.
And stay with us, too. We're going to talk weather with our meteorologist, Adam Shawinski. We're starting off on a sunny note this week, so take advantage. We'll see you in just a few.